Okay, so let's add a switch to our LED schematic that we did in previous tutorial, remember? Switch to our LED schematic. Now, in the circuit given here, we have a battery of 9 volt, a switch which is in open position right now, a resistance of 220 ohms, and an LED. Okay. Now this circuit, if the switch is closed, of course, right now it's in open position, but just assume that if this switch is closed, in that case this circuit is going to be a series circuit, right? Why? Because there is only one path for the current to flow through it, right? We have discussed about it, right? It's a series circuit. Okay, so now here is the current. Now consider the position of my switch here in this circuit. Okay, right now it's in open position. Okay, now current, because this switch is in open position, current cannot flow through the circuit, right? Current cannot flow because it's an open path, right? Open path. Now because there is no current, LED cannot brighten, or LED is in off position, right? LED would be in off position. Now let's make our switch close, or let's close our switch. Now push the button, whatever you want to say. Okay, close the switch. Now the current has a path to flow, and it will flow from positive to negative like this. It's a closed path, right? It's a closed path. And the LED will glow because the current is flowing through it, right? Okay. Okay, now let's see how the switch works. Okay, now here on the left side of the image we have a switch. Okay, it's a four-leg switch. The image on the right, this is how your switch looks from inside. Okay, now if you look at the top two legs vertically from on the left side of the switch, the top two leg on the left side, this is how your legs are connected. This is how your legs are connected. They are shorted. Okay, they're shorted with each other. Likewise, the legs on the right side, if you look vertically, they are shorted with each other. Now both these legs are separated by each other with this open circuit, which is the push button. Okay, the push button which is mounted on the assembly. This actually works as a tiebreaker here. Okay, now the moment you press this button, the circuit becomes closed and it let the current pass through it. Okay, you just press the circuit becomes closed. Okay, and this happens when you press the button. Okay, yeah. Okay, so even though this switch is four-leg switch, I mean, people say that this is a four-leg switch, but if you look the internal assembly of this switch, this is essentially just two-leg switch, right? Essentially just two-leg switch. This is the leg number 1, leg number 2, just like so, right? So this is your leg number 1, and this constitutes your leg number 2. Okay, so let's see how the switch is connected on the breadboard. Okay, now here is on the left the simple schematic of the switch. Here is my leg 1, leg 2. Here is my leg 1, leg 2. On the right here, this is how the switch is going to be placed on the breadboard. Okay, the switch needs to be placed as it is shown here in the picture. This is important. You cannot connect it anywhere else on the prototyping area. That's super critical to know. Okay, we discussed about it right in the previous video. Now because of the internal shorting of the vertical legs of this push button, the entire column as shown by yellow dots here, this becomes vertically connected, right? This entire column, this becomes vertically connected, isn't it? Which means if you want to connect any component to the switch's left side, you can connect that component anywhere on that column. Okay, anywhere, because these are all same. These holes are vertically connected, right? Likewise for the other leg on the green dots. Okay, these are also this entire column becomes vertically shorted. This is same. If you want to connect any component, you can connect anywhere because this is all the same, right? This is same. This is my leg 1 and 2. Okay. Okay, so here is my switch and LED circuit as we discussed in the previous video. Here is my battery, 9-volt battery, and this is connected to my switch. I'm giving the points 1, 2, 3, 4 just for the sake of convenience so that you can easily understand what is connected where and the sequence how to connect it. Okay. Now the positive of the battery is going to be connected to the left side of the switch, which is point number 1 here. Okay. And the point number 2, which is the right side of the vertical leg of my switch, is connected with first end of resistance, which could be either end. Okay, because the resistance has no polarity, so it could be connected either way. So there's no number 1 and 2. You can connect it either way as you like. Now the other end of the resistance is connected with the positive of my LED, and the negative of my LED is connected with the ground. Okay, or the negative terminal of the battery. So let's connect this circuit on the breadboard. This is a series circuit, right? So here is my battery. This is my positive terminal in the red. So I connect this positive to the bus. So my entire bus is positively charged, right? Likewise, I connected the ground and this entire bus became ground. Okay. Now, the point number 1, which is the left leg of my switch, is connected with the positive bus, as you can see in the diagram right here. So all these green buttons, these are the same, right? So this is connected. The point number 1, there is a positive supply extended, right? Here. So this is my point number 1, okay. And the second leg is point number 2. Point number 3 is the other leg of the other end of the resistance, which is connected with the positive of my LED, and the negative is connected with the ground, okay, just like so. And that's how this circuit is connected. Now the moment you will press the switch or close the circuit, the current will start flowing through it, okay, and LED will glow. Let's see this in practice in the next video, how this works actually. Okay.